Hi everyone, we are continuing with operations with polynomials today. Specifically, we are going to look at operations that involve fractions or division, so quotients of polynomials. I was going to start out here at the beginning with sort of a refresher on some basic fraction skills. I think for the sake of making this video not excruciatingly long, I'm going to skip over that. We can always come back to it and review it later if we feel like we need to. But I'm going to just start in this first section, and I think I'll write out the first example and then maybe just talk through the second one. But this is dividing by a monomial. So what you'll notice is this is when I have multiple terms up at the top, and those terms are separated with plus and minus, and we're dividing them all by a single term. This works along the same lines as the distributive property, but kind of in reverse, where you're dividing instead of multiplying. So what we are going to do is we are going to divide each one of these separately by that 2ab squared. So it's almost like, let's see, it's almost like I'm taking each one of these things and giving them their own 2ab squared, and then giving this one 2ab squared. Sorry, there we go. And then dividing them all individually. So doing a division problem here, division problem here, division problem here. What I want you to remember about dividing with exponents is that you're going to divide the coefficients, but the exponents themselves you're going to subtract, okay? Because it's like you're taking one off of that power. So when I do this first one, 8 over 2, right here, 8 over 2 is going to give me 4. When I put a to the fourth and divide it by a, that's going to leave me with a to the third. And then b to the sixth over b squared would be b to the fourth. So I'm subtracting my powers there. And then I'm going to go plus, because there's this plus sign here. So plus 16 divided by 2 is 8. A over a is just going to cancel out. Those are just gone. And then b cubed over b squared leaves you with just a single b. Minus, and then 10 divided by 2 gives me 5. A cubed over a is going to leave me with a squared. And b squared over b squared cancels out because they're both the same. And so this thing that's left here written in blue, that would be your final answer. So when I look at that next example, when I'm taking all of these things and dividing by y, really what's going to happen is this thing's going to stay looking almost exactly the same, just each one of these is going to lose a y. Okay, we're taking one y off of each term. So as long as you remember in those cases to do it to each term, you're good to go. So when I look at that next set, and we almost should have done these before we did the other ones, the dividing by a monomial, when we're reducing fractions here, this is the same as what we were doing up above. We're going to divide the two numbers. We're going to divide the 21 and the 3, and then all of my exponents are just going to subtract. So as a final answer here, I would end up with 7 x to the 4th, y to the 3rd. And then do pay attention to this. When I subtract the z's, I have 2 on top and 8 on the bottom. Technically, that would give me a z to the negative 6th power. See if you remember what a negative exponent does, or how we deal with negative exponents. What's going to happen here, let's see, is that z to the negative 6 is actually going to move to the bottom of the fraction. It really means that you're working with like a reciprocal. So you're going to have z to the 6th on the bottom, and then it's not going to be up on the top anymore. And this thing would be your final answer. And that should make sense to you if you're looking at this, because if you think about 2 z's being up here and 8 z's being down here, if you cancel the 2 out, the 6 remaining are going to be down in the bottom with that z to the 8th. Okay? So that's what your final answer would look like. So now let's talk about this one that involves not just simplifying, but multiplication. Okay? When you're multiplying two fractions, and specifically when they're all monomials, right? This is a single term, this is a single term, this and this, both single terms. You are technically allowed to cancel anything on the top with anything on the bottom. Okay, you can reduce it, you can cancel it out, whatever works for you. So when I look at that question, I'm going to make this a little bit bigger so I can scribble on it here. For example, I see 6 over 3, and I can reduce that to 2 over 1. Okay, so 6 over 3 would reduce to 2 over 1. 14 and 12 both can be divided by 2, so I can make this a 7 and I can make this a 6. When I'm looking at the variables here, I have m to the 4th here and m here. So if I cancel those out, I'm going to get rid of this m, and now I have 3 m's left here. My n's, I have an n up here and an n squared down here. So if I reduce those, I'm going to lose this one, and then down here I'm going to lose one of those two. So I'm left with just a single n. Okay. A's, I have 8 A's here. I have 3 A's here. So I'm going to cancel these 3 with 3 from up top, and that a to the 8th is now an a to the 5th. And then my B I don't think can cancel with anything. Nope, I don't think so. Oh, one other place, and this didn't pop up until after I did my other step, but I see a 2 here and a 6 here. Those two things can reduce as well. 2 over 6 really reduces to 1 over 3. So remember, you can reduce anything on the top with anything on the bottom. And that means that if I were to put this all back together, I have, let's see, I have 7, m to the 3rd, let's see, I don't have my n there. This just became a 1, and I don't really care about a 1, right? I can multiply by 1. And then I have an a to the 5th. On the bottom, I've got, let's see, a 1, and I don't care about a 1. We got rid of our a's here. I do have a b squared. Over here, I have a 3, and so that 3 should really go in front of the b squared. And I've got an n hanging out over here. Now, I wouldn't care if your letters came out in a different order here. What you do want to check and make sure is that you don't have anything left that can still reduce. So if you somehow ended up with m's on the top and m's on the bottom, you would want to go through and reduce them. Okay? Your alternative to this, the other way you could have gone about this one, is without doing any of that reducing, you could have just started multiplying all this stuff together and all this stuff together to make one big fraction like this. But then you would have had to go through and reduce it kind of like we did, whoops, it's not letting me slide, kind of like we did in this example up here, okay, where you had that big fraction and you were going through and reducing all the pieces. So if you wanted to put the top and the bottoms together first and then reduce, that would be fine too. Okay, these next two require a little bit of factoring. We haven't technically learned factoring, but you should know enough of it from last year to be able to handle these problems, okay? So what I don't want to see you doing is you can't just come in here and say, oh, I'm going to cross off these x's or I'm going to cross off these y's, because this is part of an addition problem and this is part of an addition problem, and you can't cancel addition using division. Okay, you can cancel multiplication using division. So what I want to do is rewrite this as factors. I want to rewrite it as something times something else. And actually this top one can't really factor because there's nothing in common between x and 2y. But if you look down here, 3x and 6y, the 3 and the 6 share a 2 in common. I'm sorry, not a 2 in common. They share a 3 in common as far as a common factor goes. So what I'm going to do on the bottom here is I'm going to rewrite this thing as 3, and then inside the parentheses I'm going to say what's left over. So if I took the 3 off the x, I'm left with just an x. And then if I took a 3 out of the 6, that's going to be a 2y. And if you want to check right here, if I distribute the 3 back in here, it would give me back 3x plus 6y. And now this right here is multiplication. Okay, so because that's multiplication, now I can take this entire thing and cancel it with this entire thing, because I can use division here. Here's my division line to cancel multiplication. I've got this divided by this. Really, I want to think of it as though there were a 1 sitting out here in front of these parentheses, and then if you think about getting rid of those, what you're left with is just the 1 over 3. So this whole thing would reduce to 1/3. Why don't you take a quick second, I'm going to pause here. try factoring this next one. See if there's anything that you can see that would factor out of the top and or the bottom that might be helpful to us. I would take the top and say they have a 3 in common. I can pull a 3 out of both of those. So I'm going to write this as 3 times x, okay, minus, and then 3 times what makes 9, that would be a 3, and I still have my y here, so 3 times x minus 3y. On the bottom, these two things have a 6 in common, so 6, and then I'm left with an m plus 2n. Okay, so I divided that 12 by 6. So looking at this time my parentheses don't match, right? This and this don't match each other, so I can't cancel them out like I did in the one above. But I do have a 3 over 6 sitting here now, and I'm allowed to mess with those using this division bar because they're multiplication problems, okay, because they're written as multiplication. 3 over 6 can be reduced to 1 over 2, so that's really what I'm doing. I'm taking this 3 and making it a 1, taking this 6 and making it a 2, and so then my answer really is just going to look like this. Let's see if I can slide this over some. So I will have x minus 3y over, still have this 2 here, so 2 times m plus 2n. And that one doesn't reduce a whole lot, but that's where I would leave it. Okay, hopefully that's sitting well with you. Let's go ahead and flip to the next page and we will carry on. Whoops. All right, so in this next example, we're doing more reducing of fractions, which is really the same thing we were doing a minute ago. This time you will notice that I've got a division symbol in between here. This is actually going to be really similar to, gosh, we did it a couple of problems ago, but the one we just did where we multiplied two fractions together. Because remember that dividing two fractions really just turns into multiplication. What's going to happen here is we're going to take this division symbol and we're going to make it a multiplication. So I'm going to make this multiplied. Okay, I'm being a lot messier here than I probably would be if I was doing it on the board. And then we're going to take this fraction and flip it over. So we're going to make it 6y over 12x to the 9th. So when you're dividing with fractions, you're really multiplying by the reciprocal. Okay? So now, if I look at that problem in detail, once again, this is one where I can cancel anything on the top with anything on the bottom. So let's start with numbers. I see a 3 on the top and a 12 on the bottom. Okay, diagonal from each other. And so I can divide those both by 3, and I can make this a 1, and I can make this a 4. Okay, that would be kind of my first step. Then I see, I'm going to run out of colors here. I see a 2 and a 6 that can both be divided by 2. This would become a 1. This would become a 3. Okay, so I took care of my numbers first. I also could have reduced the 6 over 12. Okay, and then seeing if there was anything there that could reduce further, you know, diagonally, that would have been fine too. Okay, either way, I'm going to come out to the same answer. Then let's look at our variables here. So variable-wise, I have, well, let's see, I have an x squared with an x to the 9th. So if I cancel those out, I'm going to lose my x squared here, and my x to the 9th is now going to be an x to the 7th. Okay? Then I also have, let's see here, I have a y to the 5th here with just a regular y here, pretty sure. Yep, that's supposed to be just a regular y. So I'm going to lose this one y, and this would become a y to the 4th. Okay, I know it got to be kind of a mess there. So as a final answer, let's see what I'm putting together here. I see a 1 times a 3 on the top. So that's going to become... sorry, just trying to make myself room to write here. That's going to become a 3. Okay. I see, let's see, my x squared is gone here. My y is gone here. I think the only thing I have left on top is a 3. On the bottom, Number-wise, I have a 1 times a 4, so I have a 4. And then I have a y to the 4th and an x, okay? Or x to the 7th, I'm sorry, x to the 7th. So this would become x to the 7th, y to the 4th. And then I would double check and make sure I can't cancel anything out because I only have that 3 up on top. There's really nothing else I can do here. All right, so the next one is another division problem. So we're going to do the exact same thing. We're going to switch this to multiplication, and we're going to flip the second fraction over. So we're going to put x over 2x, or sorry, x times 2x plus 1 on the top. And we're going to put x plus 5 squared on the bottom. Now, just to make a point here, I'm going to write this out this way. And I don't know that you would need to take the time to do this, but x plus 5 squared is really like x plus 5 times x plus 5. Right? And it really doesn't want to work over there. And so now this is gone because I flipped it over. Just like before, I'm canceling anything on the top with anything on the bottom, but we have to keep in mind that the factors are really like this whole thing. This is one term or one factor. So I want to make sure that if I cancel that, I have to cancel it with an exact copy of that term. Okay? And luckily, that happens for me because you see I have a 2x plus 1 here and I have a 2x plus 1 here. So those can disappear. Up top over here, I have an x plus 5, so I can get rid of one of the x plus 5s over here. I have an x minus 7 here and an x on the top here and an x plus 5 on the bottom. But remember, you can't cancel pieces. So I can't cancel like this x with this x because this x is kind of attached to the 5 here. So as far as my answer goes, I'm going to write x minus 7 on the top over, and I have an x there also, so sorry, x times x minus 7. And then on the bottom, I'm left with an x plus 5. You could put that in parentheses. You wouldn't have to necessarily. But that's what your answer would look like. And that's as simplified as you can go. So keep in mind that you cannot cancel this x with this x because of this addition that's going on right here. Okay. I think I'm going to call it good there. I think we'll save adding fractions for when I'm back in class with you because there's some trickier things that I wanted to point out, and this has already been a little bit of a mess. So why don't you do the best that you can with sections. Let's see, this would be, the first section we did would have been section G. You're skipping H for now. We're going to come back to that. And then you're doing section I and section J, evens only. Section K pertains to this adding fractions things, which we're not going to cover today. So your assignment is only sections G, I, and J, the evens, and then finish any of the stuff from yesterday that you didn't get a chance to finish. Okay, I think that's it from me. Hope you guys have a great day, and I will see you soon.